Okay, today we are going to just a second. Yep. Tonight we have a homework number 5 is due tonight, and homework number 6 Friday. So today we are going to discuss the homework number 5. You know, the homework number 5 and 6 they are from chapter 4. In chapter 4, we discuss the probability. In chapter 2, 3, we discuss how can we describe the distribution, how can we summarize the data, right? When we have a data, when we have a sample. But the topic in chapter 4, the probability, it is totally different. So in chapter 4, we are going to discuss the probability. So many times we are rolling a die, toss a coin, or sometimes we pick a card or 2 cards from the deck of the cards, right? Yeah. So in homework number 5 and 6, even though the number 5 and 6 is not all topics from chapter 4, we are going to discuss the last topic after exam. You know, today I will email you about the exam next week, but as I told you, half of us will take the exam on Wednesday, and half of you will take the exam on Friday, because the next Monday is the holiday, so it's no class on next Monday. So we are going to take the first exam on Wednesday or Friday. I will email you, okay? And the homework number 6, it will be due Friday midnight, and it will be the last homework. It will be last homework before the exam number 1. But I will post as another homework. It will be due Wednesday midnight. It will be the homework number 7, the review homeworks. So let me merge chapter 2, chapter 3, and chapter 4. Is actually I will merge homework number 1 to 6. So I will post is another review homeworks number 7. So the exam will be similar as the review homeworks. But anyhow, you can take the paper exam in class on Wednesday or Friday. So I will email you. So do you have any question for the exam? You can ask me on Friday, because today I will email you is about the exam next week. Then if you have any other question, then please ask me on Friday or please email me. Okay. So today we are going to discuss the homework number 5. The homework number 5 has 14 questions, but yeah, most of them is a very simple one. So let me introduce you is one by one. Let me see. I think a couple of students asked me number 4. So let me see the number 4. Let me copy and paste because it is not big enough. Yes, it is number 4. In this case, we toss a coin 3 times. So this case, H means we have 3 heads from the 3 tosses, right? And the next one is the first one. The first one, we had the head, second, tail, and the third one is a head again. So can you understand? So when we toss a dime, a coin 3 times, then we have 8 possible outcomes. So when you watch the lecture video, then it is the capital S, that is a sample space. Okay? So in part A, what is a probability? We need a probability, exactly 1 head. So in this case, the 3 heads. No, it is not exactly 1 head. So only this one, and this one, and that one. So the probability will be, we have 3 outcomes, which had only 1 head out of 8. So my labs, it suggests us the fraction. So you can answer it's a 1/8. Yeah. So let me check. 1/8. 3/8. It's good, right? Let me try part B. It's a part B. Just a second, let me check. Part B. Part B asks us the first 2. You know, we tossed 3 times, but it asks us the first 2 heads. So we just look for what outcome has first 2 heads. First 2 heads. You know, the last one, it doesn't matter. Yeah, it might be head or tail. It doesn't matter. So the very first one is H, 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 and H, 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 T, only 2 of them. So the probability, the fraction will be 2 out of 8. But we have to do the simplify. When you plug the 2 out of 8, I think it is a correct answer. No problem in the exam. But you know, the MyLab is very picky. So we should simplify the fraction. So you must answer it's 1/4. So let me try 1/4. Yeah, it's a 25%. And let me finish the number 4. What is the next? All 3 tosses, same. H, H, and H, T, T, and T. It's only 2 outcomes out of 8. Again, it's a 2 out of 8. Simplify, it will be 1 out of 4. So let me answer. It's a 1 out of 4. Yes, good. And the last part, what? The third one. We just focus on the third one, okay? It doesn't matter, the first 2, but we just focus on the third one. What? Head. Yes. The third one, head. The third one, head. Yes. Yes. It's no, 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 no. How many? 4 out of 8. We must do simplify 1/2. Okay, so a couple of students asked me the number 4 last night, so you can try by yourself the number 4, and let me try the number 5. Um, you know, I have to make the smaller one, the smaller way. Yeah, it has the 4 choices. The probability is actually the probability was from the set. You know, I don't know where you discuss the set things in math, but when you discuss a sets, we made the Venn diagram. Yeah, this picture is a Venn diagram. Yeah, here it is. It's a Venn diagram. Have you ever seen the Venn diagram before? Yeah, it's some of you. Yeah, most of you. It's a Venn diagram. You know, in statistics, in chapter 4, we are going to have 2 cases. The first one is an and the next one is an or. We are going to have only 2 cases, A and B, A or B. So please remember the only 2 things. You know, in chapter 2, we have 2 cases. It's a categorical, numerical. It's a similar. We have only other 2 cases, and or. So based on the Venn diagram, I mean, actually in a Venn diagram, we have a Q, M, N, right? We have the 3 event. Yeah, we call them A, B, C, D, Q, M, N is an event. First one is Q and M. So when I focus on, let me say is that now here is A, B. It's a Q, M. It doesn't matter, right? So here's A, there's a B, and the rectangle, that is a capital S. What was the name of the capital S? It was the sample space. It's a sample space. In the lecture note, the sample space was defined as a collection of all possible outcomes. So on the Venn diagram, yeah, we use the rectangle here and 2 circles. That is the 2 event. And now we had end. End means in the middle. So we have 2 cases, and or. The first one, and, that is in the middle, the common area on a Venn diagram. So what is the answer? Q and M. Q and M in the middle. I think the choice B. Choice B is the answer. The or, okay, here is a rectangle, the sample space again. Event A, event B, 2 circles. Now, or, that means A or B. So we merge them together, A or B, the whole area. I mean the left one, right one, in the middle. The whole area is combined the 3 partitions. That is the or. So remember, we have 2 cases, and in the middle, or whole area. So now it's a part B is a Q and M. You know, Q and M is in the middle here, is a part B. But now here's one more, and N. And N. You know, the end one, it is actually the common area. So we combine the three events together, and they connected with the end. So we need the common area is among the three events. Where do you expect? Just in the middle. It's good, right? So please remember the end will be the common area in the middle. It doesn't matter. When we have 4 events, 1, 2, 3, 4. Let me say it's A, B, C, D. Then when I ask you what is the probability, A and B and C and D is actually the common area among the 4 events. So just in the middle here, right? So please remember we have two cases, and or, but the and is in the middle. Okay. So it is a number 5. Sometimes we use the Venn diagram. And number 6, the number 6 is about the, okay, let me copy here. It is a mutually exclusive. It is a very special case, the mutually exclusive. So when I make the Venn diagram, rectangle, sample space, an event of A and B, when they are mutually exclusive means this case. How do you think? A and B. There is nothing, right? Sometimes we have this kind of 2 events. For example, male or female, they are mutually exclusive. We don't have anybody as a common things. School years, you must choose freshman or sophomore, junior, senior, or higher. You have to choose one of them. So they are all mutually exclusive when they don't have any common area, right? So which one is the most correct description of the mutually exclusive? And so all of this one is about the mutually exclusive. I like this one. It's none of them is in the common area, right? So let me try the A. Yes, yeah. So here's a more description about the mutually exclusive, but please remember the Venn diagram is exactly, it's separated. When we have 3 events, yeah, I just add here the C, the event C. No common area, then we can say they are mutually exclusive. When I take the probability, when A and B are mutually exclusive, but when I take the probability, there is nothing. How much will be the probability nothing? That will be 0. You know, in the note, in the textbook, there are so many kinds of the properties or rules. The very first one, any kind of probability must be between 0 and 1. It is the very first one. So any kind of probability must be positive and less than equal to 1. It's up to 100%. So please remember, it's only up to 100%. Okay. Yeah. So please understand what is the meaning of the mutually exclusive. And now let me go to number 9. And now copy and paste number 9. See, now here we have two events, E, F, but they are mutually exclusive. So now I can make the Venn diagram, E here and F there, separated. They are mutually exclusive. But now we have two probabilities each. The E, probability of E, is the 0.41, and probability of F, that is a 0.51. But now we need the probability E or F. Before I gave you the Venn diagram, A here, B there, is absolutely there is a common area. So before, they were not mutually exclusive. But where was the A or B? And was in the middle, but or is a combine them together. Even though they are mutually exclusive, it's the same idea. We can combine them together for the probability A or B. So now just simply take the summation, probability of E, add probability of F. So the answer will be 0.41 plus 0.51. That will be 0.92. Let me check. Let me go back to the 0.92. Yes, it is. The textbook is a name, the case. It is the special addition rule. The textbook is named this summation. It is a special addition rule. Why special? It is for the special case when they are mutually exclusive. When they are mutually exclusive. It's a special addition rule. Okay? But now, let me try, it's number 10. It was number 9, and now here is a number 10. Number 10 is another one. Let me try the other one. It's number 11. Okay. Let me see. It's a number 11. We need a probability A or B, E or F again. But number 11 doesn't say they are mutually exclusive. So we can make the Venn diagram. Generally, here's a E, there is a F, right? Because they are not mutually exclusive. But still, we need a probability, the probability E or F. But number 11 gave us the probability of E, only E, F, right? I told you E or F, we have to add the left one, middle, and the right one, right? But think about that. I just add the probability of E plus probability of F. That will be 0.35 and 0.50. What happened? We add in the middle twice. Because in probability of E, there was here. And the other one, F, the probability of F, this one is a middle again. So we added the middle is a twice. So now we need the probability the E or F. We have to subtract the middle is one of the middle. So it's not only just add the two probabilities, but also we have to do minus probability of E and F. And it was given is a 0.20. So now the general case, when they are not mutually exclusive, for the probability E or F, then we just add the two probabilities, and additionally, we subtract in the middle is one time. So when I take the addition, it's a 0.35, and the 0.5, that will be 0.85, but minus 0.20, so the answer will be 0.65. So it is a general case. So the textbook is named, it is the general addition rule. Still, we added. So it is another, it's an addition rule, but the general case. So now I can summarize, we have two addition rules, the special one and the general one. It's good, right? So please watch the lecture video, and there is a more explaining. It's about the addition rules or any other rules or any other is a basic idea for the probabilities. Okay, so you can watch the lecture video. Let me try the last one. It's a number 13. Yep. Let me try. It is a number 13. It will be the last example today. Now we have 51.5 females and 10.1 are divorced. So now we have two events. One is a female, and the other one is the divorced. So who are here? Female, but it's not divorced. In the middle, female and divorced. Just a second. Who is outside? It's not female. That means it's male. It's a male is outside. So how do you think? Who are here then? Male is out of the female, right? So it's here. It must be male and divorced. And how about here then? Male, but not divorced. So can you understand who are here, who are there? Okay. And now the divorced female is a 6.2%. So now I can plug in the middle. It's a 6.2%, but the whole female, that is the 51.5%, and the whole divorced, that is the 10.1%. So now, in part A, it asks us probability of F, female. The decimals, be careful, it's the decimals, it's not percentages. So female is a 0.515. And also it asks us what is the probability of divorced with the decimals. It's a 0.101. And now it's a female and divorced in the middle. Female and divorced. That was given 0.062. Be careful. It is the 6.2%. 0.062. And now it asks us what is the probability of F or divorced. Yeah, or. Where was the or? The whole area. And the two events are not mutually exclusive. So now we can apply the general as an addition rule. So now part B, probability of F or divorced, that will be probability of a female plus probability of divorced minus probability of a female and divorced. Do you have an idea? Right? And the last one, what is the probability of male? Yeah, simply, we just 1 minus probability of female. That will be the probability of male. The others. The textbook is named, this one is the complementary rule. Complementation rule. Complementation rule or computational rule, whatever. Yeah, the others. Okay, yeah. So please try the homework number 5 is due tonight. And any question, please email me. I want to stop the Zoom meeting right now. And please, please try the homework number 5 is tonight. And any question, please ask me.